Imagine an army pouring out of a single container, totally ready to pull off a complex mission. But here's the thing. There's no general shouting orders, no central command, not even a map. Now, that might sound like something straight out of science fiction, but it actually happened just last year in a warehouse in the UK. So let's break down exactly what this is and, more importantly, how it works.
So here are the raw numbers from that trial. You've got 400 small autonomous robots. They're given just one single shared objective. Go map this massive, unfamiliar space. And remember, no one's in charge. There's no leader coordinating them. All they have is a set of simple, shared rules.
And the result? Well, it's pretty staggering. In just 43 minutes, this leaderless army created a centimeter-accurate 30D model of a 10,000 square meter warehouse. This wasn't just some lab test, This was the moment Swarm Robotics became a real commercial thing. But how on earth does that even work?
Well, the secret isn't what you might think. It's not about building a few hundred super smart robots. It's kind of the opposite. The real genius here is in something called disciplined stupidity, and it's a blueprint we've taken directly from nature. This is the core idea right here, swarm intelligence. Think about an ant colony finding the fastest way to a food source, or a huge school of fish moving like a single entity to escape a predator. No single ant or fish has any clue what the big picture is. They're just following really simple local rules. The intelligence, it just emerges from the group.
The whole system, the whole shebang, is built on just 3 simple sets of rules. First up is flocking. It's just basic commands like separate, align, cohere. Basically, don't crash into your friends, but stick together. The second is state changes, which lets a robot switch from, say, exploring on its own to recruiting others when it finds something interesting. And third, they follow virtual trails, which are pretty much digital pheromones left by other bots to mark a path. That's it. These incredibly simple rules create unbelievably complex, coordinated behavior. Okay, so now that we've got the basic idea, where is this technology actually being used? The truth is, these applications are spreading way faster than you might think, from disaster zones to, believe it or not, our dinner plates. Let's take a look at a few examples. So here's a problem for you. This is one of the classic killer apps for swarm tech. After a total disaster like the Fukushima meltdown, sending humans into radioactive rubble is incredibly slow and just unbelievably dangerous. So what's the alternative? Well, the European Union's Smarrow project came up with a pretty brilliant solution. They took a mixed swarm of 40 flying and driving robots, loaded them up with sensors, and let them loose in their test site, a collapsed parking garage. Now, the key piece of tech here is something they call mergeable nervous systems. Just think of it like this. Every robot is constantly broadcasting its tiny piece of the map, and its neighbors just instantly absorb that data, stitching it all together into a bigger, shared picture. And the beauty of this approach is that even when some of the robots are out of communication range, the swarm as a whole can still build a complete, unified map of the disaster zone. It creates a system with absolutely no single point of failure. Okay, so let's jump from disaster zones to something a lot closer to home, farming. For years, the big question has always been whether small robots could ever actually be cheaper than traditional human farm labor. Well, out in California's Salinas Valley, a company called Farm is proving that the answer is a resounding yes. They're deploying these little squads of small electric robots. They navigate using just their cameras, and they can identify and mechanically pull out weeds with a stunning 97% accuracy, all without spraying a single drop of herbicide. And here's the real headline. This year, 2024, was the tipping point. The cost for these swarms to do the job finally dropped below the cost of paying a human crew. This isn't some future prediction. It's happening right now. All right, let's go to one of the most hostile environments on the entire planet, the deep ocean. Down there, GPS is totally useless. Normal radio communication? Impossible. So how could a swarm possibly coordinate down there? So MIT's Bluebottle Swarm has an answer. They communicate using these really sophisticated acoustic signals. It's basically a complex language of pings and clicks sent through the water. This lets them hold a tight formation even in strong currents, and they've already mapped coral reefs at 1/10 of the cost of using a single large ship. But get this is the amazing part. They even work together. 8 units locked on to turn a valve on a mock oil well, a task no single one of them could have done alone. Now, with capabilities like that, the jump to defense applications was, well, maybe it was inevitable. And this is where the technology becomes both incredibly powerful and
deeply, deeply controversial. I mean, just look at the difference in an urban combat scenario. A traditional human-led assault is methodical, it's slow, and it puts human lives at extreme risk. An autonomous swarm, on the other hand, it can operate at inhuman speeds with zero direct risk to the human operator, who could be miles and miles away. And this isn't just theoretical. DARPA, the U.S. Defense Research Agency, just wrapped up a program called Offset. In its final demo, 180 autonomous drones and ground bots were given one single high-level command: clear that building. And they did it in under 9 minutes. The technical achievement there is just undeniable. So this brings up a really critical question, right? An army that can be deployed can also be attacked. So what happens when a swarm starts taking losses? Well, the answer is a design principle called graceful degradation. This project in the Venice Lagoon is a really fascinating real-world test of this idea. The swarm was made up of different kinds of robots that all had specialized jobs. Some were like floating solar panels, harvesting energy. Some sat on the bottom and acted as memory storage. Others zipped around like fish, ferrying information. Then, the researchers deliberately destroyed 40% of the entire swarm. The result was just astonishing. The remaining 60% of the swarm didn't just give up. Within a few hours, it had completely reorganized itself, redistributed all the critical tasks, and just kept on going with its original mission of long-term environmental monitoring. It was wounded, for sure, but it wasn't broken. You know, all of this really points to a fundamental shift in how we should be thinking about the future of robotics. Our sci-fi dreams of these giant, complex humanoid robots, they might be completely wrong. Of course, we're still in the early days. Today's swarms, they can struggle in really cluttered spaces, and they're vulnerable to having their communications jammed. But when you look ahead, the potential is just vast. We're talking about swarms that could fight wildfires or repair coral reefs one piece at a time, to those that will, for better or worse, continue to change the face of warfare itself. And this quote from the source material just perfectly captures this new way of thinking. Forget the single, giant, towering machine. The future is a massive number of simple, cheap, and disposable units that can work together to achieve what once seemed absolutely impossible: a carpet of clever gravel. Which leaves us with one last and pretty profound question. In a system with no leader, no central brain, a system where intelligence is just an emergent property of the group, who or what is ultimately responsible for its actions? That's something we're all going to have to grapple with as these swarms move from the warehouse floor and out into our world.